Question 14. The diagram shows a 5 metre wide section of road that has a uniform gradient. The shaded area represents level ground. Two cyclists, Daleth and Johan, approach this section of road. Daleth cycles straight up the middle of the road as shown by the arrow. Johan thinks this section of road might be too steep to cycle straight up, so he decides to cycle from A to B on a straight line. So I'm going to draw that on. So he's using this route here, going from A to B. Okay. How far does Johan cycle going from A to B? Okay. So I'm going to use Pythagoras and trigonometry in this 3D shape to work it out. So I know that this here is a right angle. Okay, so I'm going to use this triangle here to work out this length here. But first of all, I need to know this length. So I'm going to use trigonometry to work that out because I've got an angle and a side. So I'm going to label my sides. So this is opposite, this would be hypotenuse, and this would be adjacent. I don't need the adjacent because I want to work out the hypotenuse. So I'm working with SO. So draw out my triangle, SOH. I'm working out the H, so H equals O over sine of the angle. O is 1 over sine 7.1. So I put that into my calculator. 1 divided by sine of 7.1 equals 8.09 metres. So I know this length now is 8.09 metres. So I can now use Pythagoras to work it out. So I'm going to do, we're working out the longest side, so it's 5 squared plus 8.09 squared. 5 squared plus 8.09 squared, and that gives me 90.4481. So AB equals the square root of 90.4481. The square root of my answer. So that length there is 9.5 metres. I'm going to write that on my diagram now because I've got a funny feeling it's going to help me in part B. So 9.5 metres. Okay, part B then. Show that Johan's route up this section of road is less steep than Daleth's route. You must show all your workings. So we've got an angle to work out now, but it's how we're going to use what we've got here to work out that angle. Well, we need it from the shaded area, which is the level ground, to this angle here. So we're going to use this. I'm going to draw a line across here. So I want to work out that angle there, and I'm going to be using this side here and my length that I've just found out to work out this angle size. Okay, so this is for part B. So I'm going to forget what I've got on here already with letters, and then I'm going to label it up. Again, it's a right angle triangle because it's at a tangent, it's at a perpendicular to this height here. So this is a right angle down here. So what I've got is, I've got my opposite here, and I've also got my hypotenuse. So I'm going to be using SO again, okay, but this time to work out the angle. So SO, I'm going to draw out my triangle to help me. And we're using S, so it's sine of theta, and it's O over H. Okay, remember when we're working out an angle, we do the inverse, so it's sine to the -1. O is my 1 metre over what I've just worked out, so 9.5. I'm going to put that into my calculator. So shift sine to the -1 of 1 divided by 9.5. And it gives me the answer of 6.04 degrees. Okay, let's just double check the question. So it says, show that Johan's route up this section is less steep. Well, we've proved that it's less steep because it's less than 7.1, which is what Daleth said.